Hi everyone, today we are discussing linear transformations. In other words, what happens when I move a line up, down, left, right, flip it, and what is it called, and what do the equations look like? Okay, so the first thing we're going to talk about are vertical shifts. Vertical shifts are when we move the lines up or down. Okay, so if I move the line up, then that means that you're going to have a positive number at the end of your equation. If I move the line down, then I would have a negative number. Okay, so here in the yellow, f of x plus k, that means that whatever k is you're going up or down. Okay, such as we have x plus 3, that would be going up. X minus 3 would be down. Horizontal shift is if I took the line and I slid it along the x-axis. In other words, I just moved it left or right. Now, technically, that means that I am moving minus h. Okay, here h represents the left or right movement. Okay, sometimes when we write equations like this, you can see that I have things such as x minus 2 in parentheses minus 3. This minus 2 inside of the parentheses represents that I'm going to the right 2 spaces. Okay, if it had been a positive 2, then I would go to the left 2 spaces. But normally we don't see this very much with our linears. We see it with quadratics, which we will do at a later time. Vertical stretch or compression, okay, looks at slope. So if I have a slope and it's more, then that is a stretch. I'm stretching upward faster than you are, okay? If I have a slope that is a fraction, then that means it's a compression. Compression means that I'm not going as fast as you are, okay? So down here for an example, if I had a 2, f of x is 2 times x plus 1, then this would tell me that because I have a 2, I have a stretch. The original had a 1, now I have a 2, okay? If I had, let me turn on some tools. Okay, so let's say up here for an example, and we're going to call this F, and we're going to call this one G. So let's say f of x was equal to 2x, and the other line was 5x. You can see that the red line up here has a higher slope. Therefore, this would be a stretch. Okay. If I had f of x equal to 2x, and then I had g of x equal to, let's say, a 1/2 x, then this would be a compress. Okay, so if your line is getting taller, such as this one, okay, then we have a stretch. Okay, if that line got smaller, in other words, a smaller slope, then that would be a compress. Horizontally, we could have horizontal movement if they are joined at the same point and then we move left and right. We don't really have this a lot in our linears, okay, but we could notice if someone had drawn a line to show where the points go that we would have a horizontal movement. It also shows up if you have parallel lines. You can tell if the line shifted left or right. Okay. And then we also have reflections. Now, reflections can go across the x-axis or the y-axis, But when you have lines, it just looks like they flipped from positive to negative. Okay, even though they are two different things, what we're going to notice is that we switch from a positive line to a negative line, meaning their slopes. So right now we're just going to focus on reflection as a single instead of being across a specific axis. So let's just talk about a few of these, and we just want to recognize what they are and maybe write down a couple of equations. So here we have y equals x. We want to write the new equation according to what it tells us. So for number one, it says vertically translated down 3 units. Okay, so this would be y equals x minus 3. I'm going down. Minus 3 hanging off the back end. If I was going up, it would have been positive. Okay, number two, a vertical compression by a factor of 1/4. Okay, so y is equal to 1/4 x. Okay, this is less than 1, it's a fraction. Okay, so therefore I'm compressing. Number three, horizontal translation 5 units to the left. Okay, now remember we had to write left inside of parentheses. Okay, it's actually the opposite. So this one's going to be the hard one. Okay, if I was going to the right, then you write it the other way. Okay, so it's opposites. And then number four, a reflection. Okay, reflection, you just have the negative slope out there. Okay. All right, so we're just talking about the parent function y equals x. We're just talking about a basic function. We're not going to try to combine functions here. All right, so very, very simple. Up, down. This was compress. So let me go up here, back up to number two. So a stretch might be y equals 8x, okay? And you can combine things to have multiples. Okay, so I could have a reflection and a compression all at the same time. That means I would have had the negative and the 1/4. Okay, or I could have had the 1/4 and it going down at the same time. Okay, so you're not just limited to one, you could have multiples. All right, the last thing you're going to have to do is recognize them by a graph. Okay, so describe each transformation on the graph. Blue is the original, red is the transformed line. In other words, what happened? And we just want to describe them. If I look at them, what happened here? Okay, so as I am looking, and I'm looking at this first one, notice that they have marked these 2 points here. This is the same point. So that means that this moved up. So this would be a vertical shift. And right now I just want you to know which direction you went. Okay, you would normally sit and count off how many it went. So if I wanted to count it, 1, 2, 3, 4, 5, and we could say up 5 units. All right, if I look at the second one, now we can see that these have shifted a little bit. So if I look from point to point, okay, what happened here? So we definitely went up. So we have a vertical shift up, and how many? Up 2. We also have a horizontal. This point to go from this point here to here actually went left 1. So this would be a horizontal shift left 1 unit. Okay, we do not have any reflections. We do not have any of the other things. I just did this wrong. I'm sorry. Let's back up for a second. We have a vertical shift down. I'm sorry, we go from blue to red. That's my fault. So here, let me fix this. Start this one all over again. My apologies. So here, to go from blue to red, we went down to, so vertical shift down 2 units, and we went to the right, so horizontal shift right, and we only went 1 unit. Okay. All right, on the third one, now you're going from a positive slope to a negative slope. So this is the reflection. Okay, and they look like they're identically the same or close to being the same. Right now I just want you guys to see that that is a reflection. However, on this last one, okay, we have a reflection. Yes or no? Okay. When I had the reflection over in number 3, they went from positive slope to negative slope. Okay. But here, there is no reflection. Both slopes are negative. I'm sorry, positive. So there's no reflection. What we have going from the blue to the red is a vertical compression. Okay, we're not going to figure out what it is from a graph. We just need to know that it actually is a compression, and it is a compression because the slope of the blue line is larger than the slope of the red line. Okay, we don't know by how much right now, we just know that there is a difference. Okay, so those are examples of our linear transformations.